Hello. Today we are going to be talking about types of variation. So our first type of variation is direct variation. So something will say like these things vary directly. If that is the case, what that's going to happen is it's going to be y equals k times x. So y is going to be some sort of multiple of k, either multiplying by a whole number or a fraction or whatever, as long as this k is not 0 and as long as this does not have a y-intercept, if you will. This is normally, like when you look at it, it's in slope-intercept form, where k is your slope. It's just your y-intercept is 0. So looking at these ones, all of your graphs should go through the origin, and they will look like this or this, some sort of linear function with a slope with a y-intercept of 0, 0. K is called your constant of variation. That is going to be in all of the different types of variation. You're going to have a K value. So in these problems, you'll see something like A varies directly with B. So you can see that it's using that word there. When it has that, A is the thing that's varying directly. So that is going to be where you could do A equals K times whatever it's varying directly with. So the constant of variation, we don't know what that is, but we know when A is 6, B is 8. So that tells us enough information to solve for K. And our constant of variation should be 3/4. When we know our constant of variation, then what we can do is we can go ahead and plug this in and make our equation. So it should be y equals 3/4 times x. Nope, let's use a's and b's because that's what the problem uses. So we'll say a equals 3/4 of b. So that relationship always has to hold true. So now what we want to do is we want to find our b value when our a value is 9. So we're going to plug in 9 for your a. We're going to solve for b by multiplying both sides by the reciprocal. So your b value here, when you divide these and multiply, should be 12. Again, every direct variation graph is a line, and your y-intercept for all of them is 0, 0. So we'll see an application of this one with Hooke's law. So a force required to stretch a spring is a distance is directly proportional. So you notice how it says directly proportional? This means direct variation. So the force, F, is in direct variation with the distance, D, which means it's going to be F equals some sort of constant times the distance. So the force of 3 newtons stretches the spring 15 centimeters. That is your distance, which makes your constant of variation 1/5. So now what we're going to do is we're going to use the force of 4 newtons with our constant of 1/5 to find the distance. And so multiplying by 5, we would see that the distance would be 20, and I think our units, centimeters for this one. So that's direct variation, where your one is equal to a constant times the other. The next type is going to be called inverse variation. So you'll see something like y varies inversely. So when this happens, you're still going to have that constant of variation, but instead of being y equals k times x, it's y equals k over x. You can rewrite this to say x times y equals k, but we're going to focus more on our y equals k over x equation most of the time. If you were to graph this, our asymptote here would be x equals 0 and also y equals 0. And so this is going to be a ratio here, or a rational function. This is called a hyperbola. That's the stuff we did in 9.3, and this one involves like not moving around at all. Just it's centered at 0, 0 for both of your asymptotes. So let's see an example here. P varies inversely with R. So P is varying inversely with R, means it's going to be P equals K over R. We want to write our equation if P is 6 when R is 10, meaning our K value here would be 60. And we can use that to write an equation. So P equals 60 over whatever your R value is. Now we want to use our equation to find P when R is 5. So P would equal 12. So same idea as before, you have to find the constant of variation first, and then you use the constant of variation in the next problem. So what I'd like you to do is take a look at B, pause the video, and you try it yourself first, using what we did with Hooke's law from above, but with inverse variation. Okay, so after trying this yourself, now we can go ahead and go over it. Our equation here, our time would equal the constant of variation over your rate. So your constant of variation, when you solve that, should be 188. Now in this situation, that is representing your distance that you're traveling. So therefore, if you take that 188 and divide by your rate, or 55, that would tell you how long it's going to take. So 3.4 hours for this one. So we have direct variation, y equals kx. Inverse variation, y equals k over x. Another kind is joint variation. So again, it's going to state like some value varying jointly. So it's going to always be whatever that value is equals. And then the other two here are going to be multiplied together times your constant. So it is like direct variation, but with another joint part to it. So like y equals kx, this one is z equals k times x times y. But you can always throw in different variables here. So y varies jointly, means it's going to be y equals k times, and they're all going to be in the numerator here, p and q squared. So we're still going to be multiplying. There's no division because it's varying jointly. So y equals k times p times q squared. So now we have all of this. We want to find P overall. So what we're going to do is we're going to divide this up. All of this first information goes together. So we're going to plug in Y, P, and Q. And we're going to solve for K. Then we're going to use that value of K to answer this question. So Y is 6, K is 1/6, P we don't know, Q is going to be 3 squared. So 3 squared becomes 9. Oops, that's times P. So if we're going to go ahead and multiply by 2/3, P would be 4 in this situation. So we have 3 different types of variation, again, direct, inverse, and joint, and then our fourth and final one is going to be a combination of the two. So y can vary both directly and inversely with different values here. So in the problem, it will tell you exactly kind of how to write things out. So as you're looking at this, let's go ahead and take a look at one example that combines this, the ERA for a picture. So the ERA, which is your A value, varies directly, so we're going to start with K, with the number of earned runs allowed, but then it also varies inversely with the number of innings pitched. So we're just going to take this and we're going to divide by the innings pitched. We have Joe Price. It has an earned run average. In this case, this is your A value, so 2.55. We don't know what our constant of variation is. The 85 earned runs is up top for R, and your innings is 300. So you take this and you solve for K. So we can write an equation here. A equals 9R over I. So this makes sense. Your ERA is 9 times the runs that were batted in, dividing by the innings that you pitched, because there's 9 innings in the game. So that's how that we could do our ERA for pitchers. So now as you're looking at this, to find the ERA, we're now going to use this with the 120 earned runs. So 120 is your A value. Nope. 120 is your R value. You're looking for your ERA. So you're going to put 120 in for R. And then the 600 innings is your I. So your earned run average, or your ERA, is going to be 1.8. So now what we're going to do is we're going to do a couple word problems and look at some equations and some graphs and put it all together. So I'd like you to look at 1 and 2, pause the video, try it for a couple minutes by yourself, and then come back and see if you got the right answer. So P equals KA over B, and then P equals KRT over the square root of S. So we want to be able to take a look at equations and identify based off of the equations if it is a joint, an inverse, a direct, or a combined. So looking at this one, most of the time, if you have like x times y equals 12, we normally have it as y equals. So we can go ahead and divide by x. And once we do that, it's a little bit easier to see that the k is 12 and this is divided by x, making this an inverse. For B, it depends on what you are viewing this as. This would be jointly if you are talking about in terms of z. If you're someone who solves for y and puts z over 2x, your constant of variation could be 1/2, and so it would be directly with z and inversely with x if you're using y as your perspective, which is what's happening here for C. So this is actually the combo here. This is directly with x and inversely with z. And for D, lastly, this one here is in slope-intercept form, so you might be tempted to say direct variation, but because of that +1, it is going to be none of the above, or neither, however you want to say that. So our last thing that we're going to do is we're going to go ahead and take a look at tables of values, and based off of this tables, we're going to figure out how they vary and write an equation. So we're either going to write y equals k times x, y equals k over x, or none. So for y equals k times x, those ones you're going to look and see, do I have a number where if I take and multiply x by a number, I can get directly to y? So if you check all of these tables, you want to see if you're multiplying by the same constant each time to go from x to y. So for instance, for A, you notice we are multiplying by 4 each and every time to go from x to y. This multiplying x by 4, this is your k value, and this is telling you this is a direct variation. So we could write this as y equals whatever x is, we're multiplying it by 4. So you can come up with an equation, and then you can even check your equation, because sometimes it's like, sometimes you have to multiply by 1/2 or a different constant or a fraction. So you can always plug in x is 3 and see you get 12 back out. But for B, it doesn't work because 10 times nothing nice equals 3. It'd have to be 3/10. And the next one, it doesn't work either. So to check for the inverse variation, K would equal X times Y. So once you've checked direct variation and established that does not work, multiply X times Y and see if you get the same thing each time. K in this case is all the same here. It's the constant of variation. It is 30. So your equation should be y equals 30 divided by x. And your last one, you're not going to multiply x to get to y by the same constant every single time. Also, when you start multiplying these together, that also does not work. So this is neither direct nor indirect. So we're just going to leave it as that. You don't have to write your equation. So down below, you can see a bunch of different examples. I'd say pick about half of them and try them out, maybe one of each different type, just to make sure everything's going okay for those. But you don't have to do all of them. Just do whatever you need to do to feel comfortable and confident with the material. On that note, I hope you have a great day. And if this is before spring break, I hope you have a fantastic spring break. Thanks.